What's up, guys? I'd like to talk today, introduce a pointer and the memory, basically the pointer's concept using the Golang. So, if you ever use only the Python and the Golang, this is a new thing for you, but I recommend you to check it out because this concept does help in the future. Um, so I quickly go to define the bump variables and name A. This is the pointer variable. Actually, I will name it pointer, and this is the pointer variables. Pointer variables also must come with an asterisk. Now, you will define a main function. Okay, so this is auto-completion enabled. I'm just gonna call it this pointer variables, and in terminal, I'll run the script, and it gives a nil. So the pointer variables always assigned the nil because nil is equivalent to the 0, and in the Go language the package level variables is always defined as the 0 value, and for the pointer variables case, which is equivalent to the nil. Now you can allocate the certain memories. So for example, this is integer, but you can also do a float. So now this has to be aligned with this one, so actually I'm gonna modify it here. So the pointer variables and then the pointer is pointing to the float 32, and this is exactly allocating new pointers memory. So now if we print the pointers again, this gives you the address of this memory. So instead of the first nil, now the pointer variables, so this is actually the variables, and then the pointer is essentially like a type. So this variables with the type pointer is pointing to the memory address, which is allocated via the new function. So this is why the pointer variables now contains the memory address. Let's continue. So now you will assign the values. So with the pointer, and then assign a new value. And I will do this way. So now I call the function. It will tell you the value. So what happened is that when you assign a new value, for this case, you will use the reference. The referencing is to fetch the value where the pointer is pointed to. So in this case, the pointer variables is pointed to this new memory allocation, which is float 32, and which contains and then assign a value 12.5, which is the value where the pointer variables where the value the pointer variables pointed to will contain. So this is why, again, when you dereferencing the value where the pointer is pointing to, now the pointer variables is returning 12.5 when it's dereferenced. It's a bit of the variables and sounds redundant, but it actually sync this concept when you keep doing it. So what about just normal pointer? This is exactly the same as before. This will return the address of this memory which is located. So now I want to do something different. I will do this operation, and it gives the different memory address. Why? Because this essentially tells, so I have the variables named the pointer, which is the pointer variables, and what it tells is that I want to get the address where the pointer variables is stored. So the pointer variables itself is also the value which is stored in the memory, which means that there is also the memory address where the pointer variable itself is stored. So just to distinguish, the pointer variables is the variable which contains the memory address of float 32, but also this variable's value has its own memory. That's what I'm trying to fetch it. And this is why when I call this externally and then the pointer, it gives the memory address, but that is different from the last pointer dereferencing. Excuse me, the pointer the variables named the pointer. Let's continue. So now I will do printf. So I'll do the referencing and then fetch the address of that. So what it does is that now I have the pointer, which is variables of the pointer value, and this pointer variables fetch the value of the pointer variable, which means that this will return the value of the pointer variables. So that is to say the 12.5, which is stored in the pointer variables dereferencing, but I want to get the address of that value, so the 12.5. So what it means that this will return the address of this memory location. So let's just run. All right. So yeah, so as you can see, this address is equivalent to the one that we first fetch, which is the pointer. So the pointer is pointing to the memory address where the float 32 is allocated. And when I do first asterisk, this is fetching the value. So that is 12.5. And 12.5 itself is located in the pointer, like the target address where the pointer is pointing to. So when I dereference that 12.5 and then try to get that address, which essentially means yeah, so it can be simplified, but this is just to get address here, and this is why these two are equivalent. And you can just continue like doing it, and this just reversing. I mean, first it get the address, and then if you get the value where the pointer is pointed to, which is 12.5, so you can just continue like pretty much forever. So yeah, and then it's just reverse. Well, in this case it's just the same operation. So that's the pointer, and thank you so much. See you next time.